This problem and all other CALC 152 problems can be found here at Sarai Studies. Link is in the description box below. This is a telescoping series, and they're asking us to find if it converges or diverges, and if it does converge, what does it converge to? And that's an interesting thing about the telescoping series is that you can actually find what it converges to by just taking the limit of the sequence of partial sums. What is a sequence of partial sums? It's just a sequence of little by little sums. So the sum of the series when you plug in 1, so up until 1, then the sum of the series up until 2, so it includes the sum of 1, and then the sum of the series up until 3, so it includes both of these. And so you can see every single time you're just adding a little bit more. So that's why it's called the sequence of partial of little by little sums. You do that up until s sub n, until the last number that you can plug in. And before that, it would be s sub n minus 1, so the second to last one, and then s sub n minus 2, and so on. And if you take the limit of these sums, in other words, as these sums go on forever to infinity, you can kind of find if they're adding up to a certain number, if they're being limited to a certain number. And if they are, then we can say that the series is converging to that certain number, to that certain sum. But first we actually have to find s sub n. So we start with actually finding s sub 1, s sub 2, until we notice a pattern. So for example, s sub 1 is literally plug in 1 into here. And we started with s sub 1 because here was 1. If it was 2, then we would have started with s sub 2. If it was 0, we would have started with s sub 0. So if I plug in 1, I get just 1, and then minus 1/3. And then s sub 2 is a sum up until 2, so that includes the sum of 1. So we just bring this down here, and then we add the sum when we plug in 2. So that's going to be 1/2 minus 1/4. And to keep things organized, let's add some parentheses. So this is done, this is done. Now let's find s sub 3. So s sub 3 is the partial sum, and s sub 3 includes a sum up until 3. So it includes these two sums. You can always just take the previous sum, because the previous sum is the sum up until that sums. And so the sum of 3 includes a sum up until 3. So it includes a sum up until 2. So we go ahead and add that. Then we do 1/3. Here's a 3. This becomes a 5. So 1/3 minus 1/5. And I'm going to do one more. So s sub 4 includes a sum up until 4. So that includes a sum up until 3. And you plug in 4, 1/4, and then 4 plus 2, that's 6. And the reason why we find more than 1 s sub n is because we want to make it easy for us to find a pattern. Because if we just did 1 and we looked at this, there's not really much to look at. Same thing over here. But then once you get to here, you kind of notice, well, this last term cancels out with this first term. And that's interesting, but that's not quite enough. So then you kind of want to make sure you do another one, and then you realize, okay, this last term cancels out with this first term, right? Because it's a negative 1/3, here's a positive 1/3, so they cancel out. And then you realize that this last term also cancels out with this first term. And then you kind of start realizing a pattern, and if you were to do another one, you would realize that all of the last terms will cancel out with a first term. So I really just look at the bottom row, and then if we follow the pattern, then we can conclude that this last term will cancel out another term over here if we continue with s sub 5 and s sub 6 and so on. And for the same reasons, this last term will end up canceling out another first term somewhere over here. And so then you ask yourself, what's left? Well, 1 is left and 1/2 is left. So already your s sub n is literally equal to 1 plus 1/2. To show the full idea, I'm also going to do the ending. So just like over here, I started with the first term, s sub 1. But I can also start with the last term. So what's s sub n? Well, it's literally this. So 1/n minus 1/n plus 2. And it includes the sum up until s sub n. So literally all of these sums and the ones in between up until here. So this is the last partial sum. And then for the sake of it, let's try s sub n minus 1. So just like over here, we went from s sub 1 to s sub 2, we increased 1. Well, here we can minus 1 from here to here to get the second to last term. So that would be wherever you see n, here you do a minus 1. So this becomes n minus 1, and this here becomes n minus 1. So positive 2 minus 1, that's just 1. So n minus 1 over here. And then here we add this as well. And then let's do another one. Let's do s sub n minus 2. So again, it's just minus 1 every time. So it's dot 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 plus, and then wherever you see n, you do a minus 2. So here's n minus 2, and then here minus 2. These cancel out, you're just left with 1/n. And that includes the rest of the sums over here. And just to be symmetrical, let's do s sub n minus 3. So dot plus, so n minus 3, and then here n minus 3 plus 2, that's n minus 1. And then we add the rest of them right over here. And then this pattern should also be the same over here. The last term cancels out first term. So I'm always going to look at the latest row that I just did. And I kind of just look at it and I'm like, okay, this is the last term minus 1/n minus 1. And then I see a positive 1/n minus 1. So it cancels out with the first term. So it remains true that a last term cancels out with the first term. This minus 1/n cancels out with this positive 1/n. And then following the same pattern, just like we did over here, we know that a last term will cancel out a first term, so this first term will be canceled out by a last term over here, and this first term will also be canceled out by a last term over here. So essentially, we're left with this and this as our remaining two terms. And here's a hint. If you had two things in the beginning that didn't cancel out, then you will have two things at the end that didn't cancel out. So then your S sub n is made up of the two things from your beginning, and then at the end minus 1 over n minus 1, and then minus 1 over n plus 2. And it makes sense that this 1 is still there, because if we're saying that a last term cancels out a first term, then this is a first term, and the only way it could cancel out is if there was a term before it, a last term to cancel out with this first one, but there isn't, so therefore this will never be canceled out. And same thing over here. Because the only last term is this one, and this one cancels something else out, then there is no last term to cancel out this one. So therefore, this also doesn't get canceled out, and we're left with S sub n being those two things. And then the same thing at the end. These are both last terms, and then there's nothing else over here to cancel out, no first terms to cancel out, and so we're just left with these. And that makes up our S sub n, and then to find what the telescoping series converges to, we just take the limit of S sub n. And then I can plug in infinity for n, so infinity minus 1 is really just infinity, because a minus 1, what is that going to do? And then minus 1 over infinity plus 2, but what is a plus 2 going to do to infinity? So just infinity. And we know that the limit of one whole, when you divide it into infinitely small pieces, that whole just becomes infinitely smaller. So small, it goes to 0. You can barely see it. So these go to 0. So you're just simply left with 3 halves as your limit, meaning that the sequence of partial sums, your sums, are adding up to 3 halves. They're converging to 3 halves. They're being limited to 3 halves. And so therefore, your telescoping series converges to 3 halves. And that's it for this video. I'll see you in the next.